guys, Mr. Mice is here, and I got another video for you. Oh, there's the bell. You're all late. Okay, so here we go. This is more examples of using implicit differentiation. I got 3 examples for you today. Okay, first one here. X cubed minus 2xy plus y cubed equals 5x. Find dy dx and evaluate for the point 1, 2. So we're going to first do implicit differentiation. So remember, we're going to take this derivative in terms of x. Okay, sorry about that, I'm back. 3x squared, okay, minus, now notice here we got x times y. So that's a product rule problem. So in parentheses, I'm going to go ahead and I'm going to say this is our first one, okay? So we're going to do the derivative of the first, 2, times the second, which is y, plus the first times the derivative of the second. What's the derivative of y? It is y prime, but we're doing dy dx. So instead of y prime, I'm going to put dy dx, okay? Again, y prime and dy dx, same thing. Alright, so that's our product rule right here. Then we've got plus y cubed, so we do the derivative, that's 3y squared times dy dx equals, remember we do the derivative of both sides. The derivative of 5x is 5. Alright, so now we're going to solve for dy dx. Again, remember that we need to put all the dy dx's on one side, everything else on the other. So don't forget here that I have to distribute that negative. So I'm going to have 3y squared dy dx minus 2x dy dx equals, okay, that's these two right here. Then I'm going to take these and put them on that side. 5 minus 3x squared plus 2y, okay? Because I subtracted 3x squared, added 2y over. Factor out a dy dx, that's the next step in our problem procedure. Right? And then finally, the last thing is to divide all of this over. So I'm going to have dy dx equals 5 minus 3x squared plus 2y all over 3y squared minus 2x. Okay, so that's the first part of the problem. The next part asks us to evaluate it for 1, 2. So we're just going to plug in 1 for x, 2 for y. So we're going to have dy dx is equal to, this is evaluated at 1, 2. So I'm going to put that there just so I know that I'm evaluating at 1, 2. 5 minus 3 times 1 squared plus 2 times 2 all over 3 times 2 squared minus 2 times 1. And that is our answer. If you want to leave it like that, because I plugged in my thing. But if you want to really, you know, simplify it out, I'm okay with this in my class. But if you want to simplify it out, I do believe this comes out to be 3/5 if I did my math right. Okay? All right, so next problem. Given x squared plus y squared equals 3, find y double prime in terms of y. So we're going to take the derivative implicitly. 2x plus 2y times y prime equals 3. Now, I need to find y double prime. So I am going to solve for y prime here. So we're going to subtract 2x. Oops, not 3, 0, right? So we're going to 2y, y prime equals negative 2x. Divide by 2y, and I get y prime equals negative x over y. Okay? So, now that I've done that, I can take the derivative again to find my second derivative. So my second derivative is going to be y double prime, right? The derivative of y prime is y double prime. Equals, so now notice here I've got a quotient rule. So low, d high, negative 1, minus high, d low. The derivative of y is y prime. Square the bottom, and away we go. Now, I asked that we put it in terms of y, so I can't leave this y prime here. I need to substitute y prime. Well, I know what y prime is. It's negative x over y. So I'm going to plug in negative x over y in for y prime over there. So y double prime is negative y plus x times x negative x over y squared. Alright, so that's how we get the second derivative. It's a little bit of work, but you can do it. Okay, I'll come back with one more. Boom. Alright guys, here we go. Last example in this video. Cotangent y equals x minus y, find dy dx. Again, we can see that we're going to do implicit differentiation because we have a cotangent of y. So, the derivative of cotangent is negative cosecant squared y times dy dx. Remember, we got to put that in there when we're doing implicit differentiation. The derivative of x is 1. The derivative of y is 1 times dy dx. So I'm going to put dy dx there. Okay? Now we're going to have all the dy dx's on one side. So I'm going to bring this guy over to this side. Negative cosecant squared y, dy dx, plus dy dx equals 1. Next step in the procedure, factor out dy dx. Negative cosecant squared y plus 1. Next step in the procedure, move it over. Dy dx equals 1 over 1 minus cosecant squared y. It's just I just switched the 1 and the minus, okay? So don't get too scared. Don't get too scared about that. There we go. Implicit differentiation later.